Hi everyone, welcome to another maths video by Maths with Sarah. So today we're going to be looking at two different vector questions. Now vectors are typically one of the more challenging topics. They quite often come up quite late on in the programme. Tends to be like the grade 8 to 9 A star A questions. And for that reason they tend to get the idea that they're a little bit more challenging, but in actual fact they can be quite simple. So both of these questions, this first one is more straightforward. I'm not saying it's easy, I'm saying it's more straightforward, whereas the second one is definitely a bit of a challenging question. Both these come straight out of exam papers. So this one is from an AQA GCSE maths paper. It's paper 1, so it's not on the calculator. It's from reasonably near the end of the paper. It's question 22, so about halfway, bit over halfway through the paper. The second one is definitely more of a challenge. That's from an Edexcel maths paper. It's from paper 3, and it's the last question on the paper. Although what makes it challenging isn't necessarily the vector part of it, but more the algebra side of it. We'll come to that one in a minute. So I'd like you to pause this video and have a think about how you would tackle these questions. So the first part is to show that you've been told and you need to prove that C to D is equal to 6a plus 4.5b. And then the second one is knowing that this is a straight line, work out what this value for k is here. Okay, so hopefully you've had a chance to have a look at this. You've paused the video, you can have a go at this question. You may not have been able to do the full thing, but hopefully you're able to have a go at it, or at least have a think about how you would tackle a question like this. So the first part of the question is saying that it wants you to show that C to D, so from here to here, is equal to 6a plus 4.5b. So the way that we do these questions, I'm just going to change to a different colour so you can easily see what I'm talking about. So the way that we do the vector questions is that we want to look at a method from getting from here to here. Now we don't know what C to D equals, we haven't been given any information about that. But what we have been told is that this distance here is 3b. From A to C, this is 3b. And from A to D is 6a plus 7.5b. So the thing with vectors is that it doesn't necessarily matter what direction you take, as long as you get from here to here. So it doesn't matter whether or not you go directly from C to D, the straightforward route, or whether or not you go from C to A and A to D. And that's what we're going to do here. So we're going to go from C to A. Now we've got the arrow on here that's saying A to C is 3b. So if we want to go in the reverse direction, we need to have minus 3b. So we're going backwards from C to A. And then we're going forwards down this line from A to D. So we can add the vector AD, which is 6a plus 7.5b. And then the last step would be to simplify this. And you can see we're going to end up with 6a, and then this will be plus 4.5b. So we've got the minus 3b plus 7.5b, which is going to equal 4.5b, which is exactly what we've been asked to show here. That from C to D is 6a plus 4.5b. Good. So we've got the first part of the question fine without any problems. So the second part of the question is looking at, I'm just going to clear all the stuff that's on here at the moment so I can scribble a little bit more in the diagram. So the second part of the question is that we've been told that from B to C to D is a straight line. And that's important because we know that whatever the gradient of this line is, this gradient is the same. The gradient of line C to D is the same. And from that, it's telling us that we should be able to work out what K is as a multiple of A. So we know that A is the distance, or K something times A is the distance from B to A, and it wants us to work out what that something is. So to go about this, we need to, we know what C to D is. We know that C to D is 6a plus 4.5b. But at the moment, we don't know what B to C is. So if we'll look at working that out first. we can do, as I said before, we don't necessarily have to go the most straightforward route. We don't know what B to C is, but we do know what B to A and then from A to C is. So from that, we can work out that B to C is K times A plus 3B. And we know that this is going to have the same gradient, or rather it's going to be the same set of multiples as this C to D is. So we know that 6A plus 4.5B is a multiple of KA plus 3B. So what do we need to times 3B by to get 4.5B? We need to times that by 1.5. So therefore, to work out what K is, we need to do the reverse. We need to do 6 divided by 1.5. And that will give us the answer to what K is. So to work out 6 divided by 1.5, we're going to have 6 over 1, so that's the same as 6. We'll just put it as a fraction. And then we're going to divide that by 3 over 2, which is a fraction for 1.5. Now, hopefully you remember about dividing fractions. The way to do it is to turn the second one over and then multiply them. So if we do 6 divided by 1 times by, flip this one here, 2 over 3, what we'll end up with, we multiply this, is 12 over 3, which is equal to 4. And therefore, from that, we know that K is 4. So if we wanted to, we could go and double check this. We could say, well, does this make sense? Does 4 times 1.5 equal 6? Yes, it does. So we've got a pretty good idea that this is likely to be right. The other thing that we can do is just to think, does that value make sense? So we know that this line is 6A plus 7.5B. So is it roughly the same as this plus this? Yeah, probably is. 4 does seem like a reasonable value for K, because we'd have this would be 4A. That does seem reasonable. If we got to say 40 or 400, we might have been questioning it, thinking that this maybe wasn't quite right. But as it is, we've got a value of 4. That seems plausible. Okay, so that was one of the more straightforward ones. The only kind of important part you need to remember about vectors is 2 things. One, that it doesn't matter what route you take. So if you're going from B to C, perfectly fine to go via A if that's the information you've been given. And secondly, that if you've got a straight line, the gradient for each of the sections on that line is going to be exactly the same. So like here, we know that the multiple that we need, or whatever we need to times B by, we're going to do the same to A. So we can work that out. The total gradient for this line is exactly the same. The section of one is a multiple of the section of the other. Okay, so hopefully you're clear on this one. Now I'm just going to clear this screen and we will go on and have a look at the second question. So this question is definitely more challenging than the first one. But again, I don't think there's anything the algebra is actually more complicated than the vector section of it. So if we look at this question, we've been given various different lines. We've got OAN is a straight line, OMB is a straight line, and APB is a straight line. We've then also been told that A to N is double the length of O to A. So we also know that O to A is known as A, which therefore means that this A to N must be 2A. We've then also been told that O to B, so the whole length of this line is B. And that M is the midpoint of O to B. So it's exactly halfway, M is exactly halfway between O and B. We've then also been told A to P is K A to B. So it's a factor of or a multiple of A to B. So we've then also been told the last bit of information, which is that M to P to N is a straight line. And using that piece of information, it wants us to find out the value of K. Okay, so pretty complicated. We've been given a lot of information, but there are various bits that we can work out reasonably easily. So let's start by thinking, so we need to know what A to B is in order to then find out what fraction A to P is in comparison to A to B. So A to B, as I said for the previous question, we can't go directly from A to B. Let me just draw these arrows on here actually, don't I? Because then we know what direction we're traveling in. So we're always going from O to A and O to B. So A to B, we're going from A backwards down A to O. So that will be minus A because we're going backwards along it. And then we're going from O to B. So, but we're going forwards along that one. So that will be plus B. So we know that A to B is minus A plus B. Okay. So the next one is, we know that M to N, M via P to N is a straight line. So let's work out what M to N is. So again, I'm just going to change the colour of this actually, because I think that might be easier if we do them all in different colours. So M to N. Again, we can't go directly there because we don't have any of those values, but we do have values for M to O. So we know that that's half of O to B, and we're going backwards. So it's going to be minus a half B, because we're going backwards down half of B, because we know that M is the midpoint. And then we can go from O to N. Now we know that this is 1A plus 2A, so that's going to be 3A, and we're all traveling in the forwards direction along these arrows, so it's going to be plus 3A. Okay, great. But that doesn't necessarily fully help us, does it? So we've got to that part, but then we want to try and work out how to get from, say, P to N. So P to N, how do we do that? We know that it's something, a fraction of A to B, but we don't know what fraction. So if we've got P to N, we're going to be going along here, a fraction. So this is where we know that it's going to be K of A to B. Now we know that A to B is, so as we've done here, we've said that it's a half of B, because we know that it's a half. With this one, we don't know what fraction it is. We just know that it's K. And again, because we're going backwards, we need to reverse the signs on this. So rather than having minus A plus B, we'll have plus A minus B, because we're going the reverse direction. So when we did A to B, that was heading in this direction. We're going backwards, so we need to reverse the signs. Okay, so we've got this first bit here, and then we need to go along this section here to get to N. Okay, so again, that one we know, because we know that that is going to be plus 2A. Now, this is where things get a little bit interesting. So we've been given P to N, we know we worked out P to N, we've worked out M to N. Now, as we did for the last part of the question, the previous question, we know that whatever we need to times B by, we need to do the same for the A's, because this line is a straight line, and therefore they're going to have gradients that are equal to each other to know that this is going to be a straight line. Similar if you're looking at parallel lines. If you want to know if two lines are parallel, are the gradients and the vectors multiples of each other? Okay, so to work this out, we're going to need to multiply the brackets out to work out a value for A and a value for B. So if we do this, we'll end up with KA minus KB plus 2A. Now what I'm going to do is rearrange this a little bit. So I'm going to make sure that it's in the same format as I've got here. So I'm going to have minus KB and then put these two together. So we'll end up with plus 2A plus KA. And now I can put this little section here into brackets. So we can leave the minus KB as it is, and then put A on the outside of a bracket, and inside that bracket we'll have 2 plus K. This is where it gets slightly more confusing, is it's actually at the point where you're looking at the algebra, so it's realizing that this is the step that you've got to do, rather than the actual vector, qualities. So what we know now is we have got a half B, and we've got minus KB. We've then got plus 3A, and we've got 2 plus K. We know that P to N is a fraction of M to N, this total line, and we just want to know what fraction this is. We know that this whole thing is one straight line, so we know that this is a portion of that. So we can say that this is, no, I've done that the wrong way around. We can say that M to N times by X, whatever fraction X is, will be equal to P to N. So we've got X or something times M to N is equal to P to N. So therefore, we know we can set each of these, we can put an X by each of these and use that with some simultaneous equations to work out what K and X are. So we have got something times or minus a half X, or something times minus a half is B, is equal to minus K. We've then also got this part of the equation here, where we know that something times 3 is equal to 2 plus K. So again, we've just added in an extra variable here to say that we know that this part of the line here is something times P to N. So, but we know that it's going to be a multiple of the same thing because this whole thing is a straight line. This is the most difficult bit, is making this connection that because this is a straight line, the total length of the line is going to be a multiple of P to N. So that's where X has come in. We know from the previous question, or the overall, this line here is going to be multiplied by something to get to this. And that's where the X's come in. We know that a half times X is going to equal, or minus a half times X is going to equal minus K, and 3 times X is going to equal 2 plus K. I'm going to rub this off now, so I can just focus on the simultaneous equations that are here, and we're aiming to work out what K is. So what's the best way of dealing with these simultaneous equations? Well, I think the easiest way to do this is to use this one here and substitute in, work out, give a value for x, and then substitute that into this equation. So if we look at this equation here, if we rearrange it, we've got a minus on both sides, so we can just remove those times both sides by -1, and that will give us x times 1/2 equals k. Well, this is the same as x over 2. So we can then times both sides by 2, and that will give us x equals 2k. We can then take this part of the equation and substitute it in here. So that will give us, where everywhere we've got an x, we'll put in 2k instead. So we'll end up with 3 times 2k equals 2 plus k. So if we multiply this out, we're going to end up with this being 6k equals 2 plus k. Now, if we subtract k from both sides, we're going to end up with 5k equals 2. We can divide both sides by 5 and we get 2/5. So we've got an answer of k equals 2/5. We could then go back and substitute this in here to work out what x is, but in actual fact, we don't need to, because we don't need to work out what x is. We've only been asked to work out what k is. The last part of this question is the thing that I always encourage people to do at the end of the question, is to check that this answer makes sense. So what we've been told is that a to p is a fraction of from a to b. So if we work out that this is 2/5 for this section compared to the whole line, probably makes sense. If this was about 2/5 and this is about 3/5, that makes sense. That makes sense with the rest of the question. If we got this as a value of, say, 6, and we're thinking this is 6 times the length of this, it's seeming pretty unreasonable. So the answer that we've got does most definitely make sense with the question if we go back to it. So that was a really tricky vectors question. It was the last question on a paper 3 from Edexcel. So it was the hardest question of the papers this year. But I actually think that it's just this step here, realizing that m to n is a multiple of p to n, is the hardest step. And then doing all the algebra, doing the simultaneous equations, figuring out all from that step is actually the hardest bit. I reckon a lot of people could have got the first few marks by just trying to work out as many different combinations of these as they could. So you got 1 mark for working out what a to b was. You got another mark for working out, say, m to p and m to n. And then it was just the last couple of marks that we were doing these simultaneous equations. So reasonably straightforward to get, say, 2 marks, much more difficult to get the full 4 marks for this question. Okay, so hopefully that made sense. Hopefully that helps you with a few of the more tricky vector questions that you'll potentially come across on these papers. As always, if you have got any questions, feel free to message me. If you've got any questions you want me to do videos of to talk through, then again, feel free to drop me a message. In the meantime, I'd really encourage you to like and subscribe so that these videos get shared with as many people as possible, and also that you find out as soon as a new video comes out. But lastly, thank you very much for watching, and I hope you found it useful.